Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a meetup group in Brisbane and concentrate on helping people get into Python, and we also have a stream on machine learning, which is probably a little bit more advanced, but anyway, Beginners Python and Machine Learning, that's what we do. So we're mostly doing online sessions, and the first session of every month we try to aim at absolute beginners. So tonight's a absolute beginners session, which means I'll just go over things reasonably quickly, but if you're finding that you can't keep up, just let me know, and I'll slow down and go over something in more detail. So I'll be watching the chat, which I'm not signed into, so I better sign into that. And the Slack is also in this Learning to Code channel. All right, so I'm just going to get my security key just a second. Yeah, sorry about that. Google had locked me out of the chat session. Okay. Now we're going to use Google Colab Notebook tonight to do our Python programming, and that way you don't even need to have Python installed on your computer. You can just run it out of a web browser. Google will give you for free a actually there'll be a VPS, that'll be a virtual private server running Ubuntu, and then that you can run Python in a Jupyter notebook on that. Okay, so I'm signed into chat. So let's start the Google Colab notebook. If you look down below the video where you're watching, and also on the meetup page, you'll see a link to colab.research.google.com, and if you click on that, that'll open up a new tab, or you probably want a new window so you can keep watching the video, and it'll give you this notebook that I've written, and you'll be able to run it at the same time. So see, it says here changes will not be saved. That's because it was written in my account, and now we're in another account. So the first thing I recommend is copying it to your own drive, and that way you can save all your changes. You don't need to do that, but it will help. Well, it's just easier for you to find it again later, because you'll be saved in your drive and you'll be able to go and make changes. All right, so there's release notes. I'm just going to close that. The first thing we want to do is connect. So you see a button over here. If you don't click on that, it'll connect automatically later. It'll just slow you down a little bit. And it's giving this warning message, which I don't need. So let me know if you're having trouble hearing in the audio, or if there's a problem with the video as well. If you have something you can't see, you need the text bigger or something like that. So tonight we're going to be looking at f-strings. Now, f-strings are a way of presenting data in Python. They were only introduced in Python 3.6, but they're very, very successful, and they've really replaced all other forms of formatting strings in Python. So, and this notebook will have some exercises on how to do it. Now, these notebooks, they're just made up of text. As you can see here, that's just formatted text in a cell. You see there's a rectangle around it, that makes it a cell, and then there's this grey shaded cell which has got code in it, and in between each of these you can add another code cell or another text cell, just as much as you like, and so it makes it possible to run these short snippets of Python code interactively, so that it you can see exactly what the output of the code is, and it's a really great way of learning, and it's actually a really great way of doing data analytics and other forms of using Python. So we're going to run this little program here. It's just 2 lines of code, and it's going to tell us what version of Python we're running. So it's just import sys and print sys.version. I won't explain now what that means, just that it you can see that we're running version 3.11.12 of Python, and it's running on this Ubuntu VPS. You can see it's giving us some RAM up here. We've got, I think it was 12.67 gigabytes of RAM and 107 gigabytes of disk storage. And so that's plenty for what we need. So to run a cell, you can click on the play button here, or you can see you can use the keystroke control enter. I've put some stuff here about help, how to get help, but if you ask questions in the chat if you want more details on that. So I normally use, you saw there where you hover, it tells you to press Control Enter to run the cell. So let's try that. I'm going to put the cursor in there. On a Mac it would be probably Command Enter. So I go Control Enter, and it runs it, and it leaves my selection in that cell. And you can see we've got this Python program here. It's got 3 lines. The first 2 lines are comments, so they've got these hash symbols at the beginning. And to make it easier to recognize that, Google Colab has color-coded the lines in green, so that they really stand out, that they're just comments, and the actual Python code there is just this bit of text here surrounded by quotation marks, and that is what we call a string. A string is a series of characters, text characters, so a string is like text. And in Python, when you're looking at types, they actually abbreviate string to str. So if we type a string here, and it's the last line, the last thing that happens in this cell, and we run it, Jupyter Notebooks will just output what the value is of that expression, and so the value is a string. So you see it's the letters for hello surrounded by quotation marks. Now let's move on to the next cell. We can assign a string to a variable. So we can take our string, which was our text surrounded by quotes, and we can store it in a memory location on our computer. And we give that memory location a name, and this time we've called it S. So it's just, we just have to remember that S, if we want to get that data out of that memory location, we just have to remember that it was called S. And so S is called a variable because you can store varying bits of data in there, and then we can do stuff with it. So we can write expressions, we do calculations, we can even print the contents of the variable out. So we're going to use the print function. So in Python, this function is the word print, and to call a function you use these parentheses. And you can see as I'm hovering over it, Google Colab is showing up help of how to use the print statement. And then we put the variable in there that we want to print. So let's run that cell. And now when it prints it, you see it actually doesn't print the quotation marks around it because this is the output that we're trying to get rather than a representation of the variable. And so it would be messy if every time we print something out we got quotation marks out. Now, as I said before, you can just put an expression here. The expression could be just a variable name rather than a literal. And in IPython, it will display the results of that. So we'll run that, and you can see there's the results, but it's in what we call the representation of the variable. So it's got the quotation marks there. For the rest of this session, we want to avoid seeing the quotation marks, so we'll use the print function. And that'll work in both IPython and normal Python. We've got hi from Pakistan, so hello Safdar Ali. Good to see you today. Now, different things we can do with the print function. I'll just run through a few of these before we get into F strings. We'll just do it with normal strings. So in the print function, we can put several variables or values in there, all separated by commas. This time we'll just put the same one twice, so C, C, and we'll print that, and we get New York space New York. So the print function will take everything separated by commas, and we'll display it, this time separated by spaces. I said before, you can have expressions with strings, so if you want to assemble strings together, you can use the plus sign to concatenate them. So here we're going to take a hello and a space, and we're going to add that to whatever's in C, which remember is New York, then a space, and then another C. So if we run that, you see we get hello New York, New York, all with no spaces in between. Now, if you want to think what would happen if we didn't put this this space here, you can quickly you can edit it there, or you can create a new code cell and just say something like print hello, I'll put a space that one, plus C, and run that. And you see it doesn't put a space in between New York and New York. So when using the plus signs, it doesn't insert spaces. When you use the print with the comma, it will put spaces in. So that's why we had to put a space, because we were using the plus sign in this case. Python has they like their metaphors, so they've converted the mathematical metaphor and adapted it to strings. So if plus adds strings together by lengthening them, the multiply symbol, which is the asterisk in Python, will multiply strings. So we can take a string, say a dash, and multiply it 40 times and see what we get. We get 40 dashes. And the string doesn't have to be a single character string to be multiplied. It could be, in this case, a 3-character string. We multiply that, and we get that long line of text, which is dash pipe dash, dash pipe dash, dash pipe dash 40 times. So I'd like to set you a few challenges, because that's you really learn by doing things. And I've left a blank cell there for you to do it. So the challenge here is to print a string of 50 underscores. So an underscore is the shift dash symbol. We can make a string by putting quotation marks around it, and we can multiply it by 50. So if I run that, there we go, I get a long line, although I do get the quotation marks around the end, which is a bit annoying, and that's the answer to the challenge. Now there's a couple of different ways of doing that. Here I provided a solution, and this is a solution using the print statement, and try to notice what other differences we've got here. So for a start, we've put a heading above our answer. So we said we want solution 1, and then we've got the 50 underscores. We've multiplied 50 times the underscore rather than underscore times 50. So it doesn't matter which way around you do that, you'll still get the same result. And let's run it and see what we get. So we go solution 1 and this long line with no quotation marks around it, and you notice that there's a line feed between the first print statement and the second print statement, and so every time you do a print, it will drop a line for the next one. Okay, print it's the other thing, did I mention the double quotes? So this is using double quotes rather than single quotes, and really they can be used interchangeably. There's a couple of places where you decide to use one or the other, but they're pretty obvious. Okay, challenge 2. Print the following line. Python wasn't built in a day. So I could do this, and I can use double quotes and copy and paste it in, and there we go. Python wasn't built in a day. And solution 2, which is the same thing with a heading, and apart from the different ending characters, the quotes and double quotes are equivalent for defining strings. Really, the main time. I see. So the reason why it makes a difference here is because we had a single quote in the string that we wanted to print. So if we tried to do this with single quotes, if I tried to print that, now I'm going to get an error, and that's because I started with a single quote, I put my string and it's got a single quote in it, and then Python thinks that's the end of the string, and then it doesn't know what this stuff is at all, or this dangling quote here, so it throws an error saying it's an unterminated string literal, which means you've got a quote and it hasn't got a paired quote, so we've got an odd number of single quotes there. So if you've got a string that's got a single quote in it, then the easiest thing to do is to surround it by double quotes. If you've got a string that's got a double quote in it, then the easiest thing you can do is surround it by single quotes. And then if you've got a string that's got both a single quote and a double quote in it, then there's other things that you can do. We won't get into that just yet. Alright, this is a new thing. I haven't seen this. Fix error. Let's see what it does. Uses AI. Great. And so in this, their solution is to escape the single quote. So still use single quotes at each end and escape it. So that would be a solution if you've got both single quotes and double quotes in your string. So let's accept that and run it, and there we go, that worked. Okay, so let's look at F strings. So an F string is pretty much the same as a normal string, except it's got an F out the front. So you can see here's an example of an F string. So outside, before the first quote or double quote, we've got the letter F. And what that says is that somewhere inside the string, we're going to have an expression that we want evaluated. We don't want to display the expression itself, we want to display the results of evaluating the expression. So a simple expression is a variable name. So if we've got a variable, say city equals Brisbane, and we put into our F string in these curly braces, we put the expression, and the expression is just city, then it will evaluate that, what's in the value of city, and substitute in Brisbane for that. So here we go, teaching about F strings from sunny Brisbane. So that was a very easy way of substituting in a value into a string. Now the expression can be a numeric variable, or we've just done text, but there's an example of a numeric variable. This is meetup number 213. Okay. So, challenge 3, calculate the quotient and remainder from dividing meetup number by weeks per year and display it in an F string. So if we've so in Python we've got a couple of operators. So you can divide, do an integer division, divided by weeks per year, and that gave me an error because I didn't run this cell. So I've got to run this one, and you can see that the number they put at the start of the cell to say that the cell was run, and you see that was number 20. So you can see I've run them out of order, but that doesn't matter because I'll now run this one again, and it's now 21. So 213 divided by 52, and it's a floor division, is 4. So if we'd been doing one of these every week, then it would have taken us 4 years to get to this number, 213. Similarly, there's another operator called the modulo operator, which is a percent, and that gives you the remainder after you divide. So 213 divided by 52 gives you 4, remainder 5. So it would have been 4 years and 5 weeks to do 213 meetups if we did one every week. So how do we put those expressions into f-strings? So let's look at the solution down here. Actually, I'll do it. I'll do it here in our cell that was left for us. So we're going to print the f-string. The f-string is going to now, because Python, Google Colab has recognized these f-strings, so it's done some color coding for us. Even though it's inside a string, it saw the curly braces and goes, all right, well, that's an expression inside the curly braces, so it's done that in black. And the text that's going to come out straight as text is done in red. And I'm going to, the first expression is going to use floor division, and the second expression is going to use modulo. And it comes up the answer, 4 years and 5 weeks. So you can you see how that worked? There's one expression, and rather than display out the expression, it displays the result of the expression, which is 4. Okay, so let's run solution 3, which looks pretty similar. It's just got a bit more text in there, and see what that looks like. Now that's come out on 2 lines, solution 3 with a heading, and then to present a numbered BPA-mail session every week would take 4 years and 5 weeks. So that's good. Now to get this new line into the text, we've used a \n. So that's another option. Rather than having to do 2 print statements, if you want a new line, you can just do a \n for the new line command. Okay, challenge 4. Print the powers of 10 from 1 to 1,000,000. Okay, and a hint, we can use the power operator, which is ***. So 1 is 10 to the 0, and 1,000,000 is 10 to the 6. So we can do a for loop. Now you haven't seen a for loop before, so if this was absolute beginner and you didn't know what you'd do, you'd have 7 print statements. But I'm going to do a for loop, and we want I to have all the values, so we go 0, 1, 2, 3, 4, 5, 6. There's the 7 values. We just want to print 10 to the power I. There we go. So we've got 1, 10, 100, and all the way up to 1,000,000. So that satisfies the challenge, but let's have a look at the solution, which might have a bit more in it. So we're going to introduce formats here. So inside the curly braces, we've got some expressions. The first expression is I, which is our loop variable, and these in the second one we've got 10 to the I, so they're the two expressions. But after the 10 to the I, we've got a colon and then a number, and that number is going to be the width that we want it to take up, and because it's a number, it will automatically be right aligned. So let's run this. Solution 4, 10 to the 0 is 1, 10 to the 1 is 10, 10 to the 2 is 100. So that was a pretty easy way of getting them all to line up. You'll see here I also use this range function, which has the same effect of typing out all the numbers individually, and that's just a bit easier because now I can go up to, you know, up to 9. 9 didn't work so well because I got bigger than 7 characters, so it had to squash them in. So I should probably make this a bit bigger as well. There we go. Now they're all lined up. Was there anything else here? So the right alignment, F strings formatting after, and I did a loop. Okay. Challenge 5. Given that a mile is 1.6 kilometers, print a conversion table of the form 1 mile equals 1.6 kilometers, 2 miles equals 3.2. Okay. So we're going to, we want a loop, and we're good. So let's say M is the number of miles, and it's going to go up to, so range takes you up to but not including the final number, so we'll go from 1 to 11. I can actually put a starting value and just past the ending value, and we're going to use F strings. So in our F strings we want to put the number of miles. M miles is M times 1.6 kilometers. Okay, and that's what we get. Now it doesn't look very good. We should have put in a width character for the number of miles so that they got lined up properly. So let's put a 2 in there. That improves it a bit. So now 1 to 10 are all lined up. But then the calculations. This is one of the issues with Python and most languages doing floating point calculations, is that they store the floating point numbers in binary, and they don't convert exactly to decimal numbers that we know. So when we come to output them, we can end up with all these zeros. So it's pretty close to 4.8, but not exactly 4.8. So it prints out this large number here. Well, it's the same number, but it's just slightly erroneous. But we can use F strings to clean up the formatting on that. Let's have a look at how to do that. So we've done the same thing here. Let's run it and see what it looks like. Yeah, it's fixed the problem for us. And how did it do it? So it's got a format here after the colon. We've said we want it to be 4 characters wide, and then we want it to show a decimal point, and then after the decimal point we want to have 1 decimal point, and then the F says it's a fixed number of decimal places is what we're going for here. So that's what that F stands for in our formatting. And that gives us a very nice outputted table. Now, when we went for F, which was a floating point, it really is fixed. There are other forms of floating point, so F means a fixed number of decimal places. We can also display it in exponential notation, and we can also display it in decimal or binary or octal or hexadecimal. So decimal is base 10, binary is base 2, octal is base 8, and hexadecimal is base 16. So let's have a look at the number of miles in all those different bases. So there's D gives us our decimal, so they're the ones we're familiar with, 0 to 15. B gives us binary, so just ones and zeros. And that's how you count up in binary, if you're familiar with that. Octal is base 8, not so common, but yeah, if you go 0 up to 7, and then you go 1 0 after 7, 1 1, 1 2, 1 3, 1 4 up to 1 7. And the next number after that would be 2 0. Then we've got hexadecimal. So hexadecimal, you can use a little x or a big X, depending on whether you want it to come out in upper or lower case, because base 16 we've only got 10 digits, so to represent 16 different numbers we have to borrow letters out of the alphabet, and so we use the letters A to F to show numbers, the other 6 remaining digits that we need. Now when we, if you remember, we had our formatted with the F number, and there's what they look like, but we can also format with E, and that's exponential notation. You might be familiar with that on your calculator. So it's a number times 10 to the power of, and that means every number can just have the single digit in front of the decimal point, and then you multiply by a number of tens to get effectively the decimal point where you want it. So 1.44 by 10 to the 1 is the same as 14.4. And exponential notation is great if you're displaying a lot of numbers that have a big range. Like some can be really small, you can go actually down to fractions of 1, or very large up to 10 to the power 100, and you could use this exponential notation to display them easily. All right. Anyway, we're getting a bit tired of using just numbers 1 to 15 here, so we want to get some real data, and I'm going to get some data from the Brisbane City Council Ferry Terminals API. So I've given you a link here if you want to explore a bit more about it. I won't go into too much detail because it's a little bit more advanced than Absolute Beginner's Python, but at least it'll give us a way of getting some data that we can then try to format in a nice way. So it's using an API. We'll be getting some JSON. We can use either the standard libraries that come with Python, or even the Python people recommend you actually, for this sort of thing, use a third-party library, which is requests. And fortunately, Google Colab has already installed requests library for us. So these are the standard libraries that we can get from Python. This is requests that in standard Python you would need to install, but for Google Colab it's already installed, so we can use it. Here's some code to go to that URL. You could try typing that straight into a Firefox browser and see the JSON that comes back from it. But let's run it. It's going to go to the ferry terminals and get at most 2 records from ferry terminals in Brisbane. And I get an error because I didn't run the cell above. So I hope you're running these at home as well, so that you're getting, this should all work on your computer as well as it's working on mine. But you do have the same problems as I do, that you have to run every cell. So here we go. Here's the results from it. It's in JSON, so it's these curly braces, and then you get a key and then a value, and the value in this case is they call it an array. In Python we call it a list, and then inside the array is these what JSON call objects, and we call dictionaries, which is more keys and values. So access notes, accessibility, bike rack no, boarding gates too. So just all interesting information. It's even got some latitudes and longitudes about where it is. Okay, so that's what the data looks like. So let's grab the whole lot of it. That was just 2 records. It tells us there's 22 records. So we needed to run that first query first because to find out how many records there were, because the API that Brisbane City Council provide, if you don't specify a record, a limit, and it'll assume 10, but we want actually all 22 records. So we could actually use f-strings here to construct our URL. So the URL is going to be all that standard bit there, but the limit we have to specify, and we don't know what the limit is yet. So we'll evaluate it from an expression, because they might be building a new ferry terminal, and by the time we run this, it might be 23 or that. So rather than hard code in the number 22, why don't we just make it as a function, an expression of the data that we got from the first API? So we'll get the dictionary from the ferry, and I said this is 2 when we asked for 2 records, and we want the field total count, so the key total count, which is this one here, and whatever the value is, which was 22. And so we're going to put the number 22 into limit, and then we're going to send that off to requests and get that URL, and therefore we can look at the status code that comes back. So 200 means successful, 404 you're probably familiar with, means file not found, URL not found, and then we go we're going to create a dictionary, which is similar to this JSON object that we got. It's the way Python does data. Won't go too much details into it, but we can refer to parts of it like the by those names, so like total count or results. So we're going to get a list of results, and then we put that into our variable called list of records, and then I'll print each one just to see what they look like, and if we don't get a status code 200, I'll print failed to retrieve data. So a little bit of error checking there just to make the program a bit nicer when it runs. And there we go. These each line is a print statement. Each one is how a dictionary has printed out. So each one is a record, and we can get things like the description, the object ID. We got the property address, the suburb, all sorts of information about it that we saw before. So these are some of the fields. I'm just going to store them in I'm going to store the field names, which are the keys in our dictionary, into some variable names, and they're going to be constant. So in Python, it's a bit of a convention that if you're storing a constant value, you put it in a variable which is all caps, and that way, if Brisbane City Council changes any of these field names, I just have to change it in one spot, and then all the rest of my code later will still work. And in fact, that's the reason I've done this. So this is an old example I've used, and Brisbane City Council did change the field names. So this time I'm a bit smarter. I'm going to store the field names in variables, and then I just have to change it in one spot should Brisbane City Council change it. If they change the structure, well then it's going to be more difficult, but this will do for now. So I'll run that, so they're all defined. Yep. Okay, challenge 6. Print ferry terminal description, latitude and longitude to match the following title row. So if I run that, you can see I've got ferry terminal, and that's going to be 35 characters wide, then the latitude, which is 17 characters wide, and then the longitude, which is 17 characters wide. All right, so for R in my list of records that I've got from the ferry terminal API, I'm going to print this. And we can see that the Gemini AI has jumped in and go, well, this is probably what you want. And it looks pretty good. So let's go with that. And what do I do? Press tab. There we go. Tab accepted it all. Uh, 35, 17, 17 and spaces. So let's print this in the same cell so we can get them together. Okay, it sort of works. The ferry terminal heading looks nice, and it's all lined up there. Latitude and longitude, the text is left aligned and the numbers are right aligned, so it doesn't actually look like they're lined up even though they are in the same cells. Alright, so let's go have a look at the solution and see what we could have done. Solution, introducing the align right operator. So in that format for our heading, we could have said we want latitude to be aligned to the right, and we do that by, after the colon which says now I'm going to give you a format, we could say the format is going to be, I want the text aligned to the right, so I'm going to put a greater than sign, and it's still going to be 17 characters wide. So if I run that, now they line up, because both the text and the numbers are aligned right for those two columns, and in the first column the text is all aligned left. Okay, challenge 7, print ferry terminal description, latitude, longitude, pontoon length, pontoon material to match the following title rows. And so we can see the latitude and longitude we're aligning right, 17, we're using the greater than sign, and pontoon length is going to be aligned right, but pontoon material I'm going to center, so rather than a greater than sign I'm going to use this circumflex. Let's have a look what that looks like. So it's a bit hard to see that they're aligned center or right, but let's do some data. So I'm going to print my same headings, and then I'm going to, for R in the list of records, yep, that's good. I'm going to print the description, I don't know why it stopped there, so description, then latitude, and then longitude, and then pontoon length, and he's got 9.1. So I think I would go 10 if I want it to line up. 10.1, and then the pontoon material. Let's put his strip in there, so he's getting rid of any white space in before or after, and he centered that, and that's also 10. So that looks good. I've got 2 spaces up there, and he's got 2 spaces. He's done well, except it didn't come out. So what did we get wrong? Oh, here we go. This should be 10.3F. And we'll do another 10.3F here. So they look good. Pontoon length. That's why I did the 9, so that it left room to put in the meters sign. That's a good idea. And now that lines up, and then this is center aligned, which you can see when they get down to concrete for this ferry terminal here. And I think he was cheating off my answer actually, because I put the 9.1F here and the strip and everything, so that all looks the same. Okay, now dates are always an interesting one for printing out. So let's have a look at what dates are in our data. So this is a typical data analytics task, is you look at your data and work out what needs to be cleaned up in it. So their inspection dates, it's got a year, month, day, and then a time. And the times appear to be either 1 o'clock in the morning or 2 o'clock in the morning. And the time zone is universal coordinated time, so +0000 00. So this is the standard ISO 8601 format for doing dates, very common in JSON. Not sure why he's doing 1 o'clock and 2 o'clock in the morning. In Brisbane, that would be 11 o'clock or midday in that they would be doing their inspections. And it seems strange that every inspection happens at 11 o'clock or midday. So what have I written here? Normally to convert this, I would parse it to a date time. However, it looks like they're using date time field to store dates. And they have a bug in their data processing so that they're using Sydney time even though they are in Brisbane. To convert string to date time, we use the string parse time format, or if you're using Python 3.7 plus, you can use from ISO format, which is a great method to use. So date time is a standard library. Zone info is also a standard library. And what are we going to do? We're going to convert this string into a date and store it in a variable, and then we're going to format the date back into a string. But if we store them in dates, we can do extra things. You can do date arithmetic. You can work out number of days between two dates. If you're storing them as strings, you can't do that sort of stuff. So storing them in dates is a great idea. You can sort them if you need to, find out when the one that's had the oldest inspection date or the newest inspection date. So that's why we would store the data as dates. But when we want to display them, obviously we want them in a format that the user can read. So then we convert them back to this format. And so %d means day, %b means the month as a word, not a number. So so the third month would be March, or the fourth month would be April. %y is the year. It's a capital Y, so it'll be 4 digits. And then hours, minutes, seconds, and then %z to give us our time zone. So if we run this bit of code, we can see that we can take the original string, which is 2024032201 and that, and we can convert that and then print it formatted like this, and that's what it will look like if we were using the string format time technique. However, F strings also give us this functionality, so we don't even need to call this method string format time on the date time object. We can just say in the F string we want the date, and in our format after the colon we say we want %d, %b, and it's really the same format of specifiers that string format time would use. The current time zone from JSON is the time zone info, and so because we use from ISO format, it formatted that and worked out that was UTC. And so in Brisbane, this time would be 11 o'clock in the morning, and Brisbane is 10 hours ahead of UTC. Challenge 8, investigate all the times in Brisbane and Sydney time zones. So we're doing a bit of data cleaning here, having a look at it. I'll just run this. So we'll go through our list of records. Each one we'll use from ISO format to convert it into a date time. And then we'll print a description of the ferry terminal, convert it to Brisbane time, and convert it to Sydney time. And this is what I was saying before. In Sydney, we've got Australian Eastern Daylight Time. That's what happens when we've got daylight saving in summertime. And then Australian Eastern Standard Time when there's no daylight saving. So in Sydney, every one of these is midday, which is weird because in Brisbane, which is where the inspections took place, that would be 11 and 12. So I think they've just got a bug in their software. They've decided to use a server down in Sydney for storing it, and Sydney's when they're putting in a date, their software just goes, assume it's midday, and then the software's running in Sydney, so it assumes it's midday Sydney time, and then it converts it back to Greenwich Mean Time, and we're getting these 11 o'clocks and 12 o'clocks. So really, to clean up the data to something more meaningful, we don't need to know the times because they're just made up anyway. We'll just use the dates. Print the description, latitude, longitude, pontoon length, pontoon material, last inspection date. So we saw, well, I'll show you just how to do it here, and then we'll run the full solution. We just want to print. I don't need to do the whole lot. So all I'll do is just the date. So we're going to print in our curly braces, and it's going to be last inspection date. We're going to, did I convert them? No, so I've got to do this. And then I can format that as %D, %B, %Y. And there's our dates. So if I just done the strings, I would have got all that time and time zone information that's really irrelevant. And all I'm really interested in is the day, month, and year. So let's have a look at the solution. Here we go. I've stored the format in a variable, so I could change it if I wanted to have all my date formats the same throughout my application. I'd store them once, and then I can just change it in that one spot, and it would, all my application would be consistent. If I run that, I can see last inspection, and there are the dates. Have I done anything in no other special formats? Oh, so the interesting thing about this is because I've stored the date format in a variable, then inside my formatting here, I can't put a variable name because it'll be treated as a literal. You know, the %B, %D, they're all literal values that I would have there in the format. So I can use these curly braces again within another set of curly braces, so that I can then evaluate this expression and then use that expression in the format for evaluating this expression. That's pretty clever. Any questions about that? We'll move on. So other nice formatting things that we might want to do. We might want to do when we're aligning operators, we might use padding. So for example, zero filling, we might want to have it 4 characters wide, but any character that's not specified we want to fill with a 0. So this is the number without 0 filling, and this is the number with 0 filling. Similarly here, there's the number without 0 filling, and there it is with 0 filling. And I've just done binary numbers to make it easier to see that, but you can do that in decimal and other numbers as well. So that's 0 filling. You can do other characters as well. Here we'll use asterisks to fill. So we want it 30 characters wide. We want it centered, so we can center the letters BPAML, and we just fill either side with asterisk so that the total width is going to come out to be 30 characters. So that's good. The logging notation. So this was introduced in Python 3.8. I think it's fantastic. I use it all the time. If I want to know what a variable is, inside the curly braces I put the equals sign, and then it'll display the value of the variable and the name of the variable. So in this case, s equals, and so it goes s equals BPAML, I to the power I equals, and it goes this really long number, which is formatted as a decimal number with commas separating every 3 characters. I can do that, which is square root of this number, which is going to have commas separating the thousands and the millions, and it's going to have 3 decimal places after the decimal point. So that's how I've specified that there. So there's some nice little formatting things that you can do. Showing braces in F strings. Sometimes you do want to show braces, but of course every time you type a brace it tries to evaluate the expression. So in that case you can just do double braces like this. So let's have a look at this string, and Google Colab's even recognized it. It's going, well, that's, you've put double braces, so we're just going to assume that's straight text that you want to display, so we're going to keep it in a red color. But this one here has got single braces, so that's an expression. So we're going to convert it to black, although the numbers within it are going to convert it to blue. And that's how really good for documenting F strings itself, because now I can say the F string F5 plus 7 evaluates to 12. You can use variables in the formatting, as we saw above with the date format, and here we're going to use it for the width of the field that we want. So we're going to use padding with dashes. We're going to have it right aligned, and the string that we're going to display is just going to be an empty string. So the width is what's going to change, and it's going to put dash signs in front of the empty string. And that's what it gives us. It gives us this sine curve in dashes. Now I could have done that without using F strings. This is another way. I could have done it using just string arithmetic. So I take the plus sign and multiply it by a number of an integer, and there's the same output not using F strings. So there's different ways of doing things. Okay, here's a few other formats. You don't use these ones so much, so I'm just quickly going over them. So G is a general format, and that'll we've done the E format, which is exponential notation, and F format, which is a fixed number of decimal places. But if you use G, it'll choose between E and F depending on what the value is. And then N is the same as G, except it uses the currently selected locale. And when you're using N or G, then precision is actually not the number of decimal places, it's the number of significant figures. So if I run this, you'll see in longitude I've gone for 5G, and so 5G means 5 significant figures, so it's done 3 numbers before the decimal place and 2 after. Similarly, so that's latitude, and also the same for longitude. For pontoon length, 9.1G, so the 1 has gone, actually I want 1 significant figure, so it's just gone 4. There's no decimal places in there. You're probably not going to do the G's much, so I won't spend too much time on them. But if you do want, one thing that N will do is use this currently selected locale. So I thought I'd give an example of how to do that. But the locale is defined, it's not on your computer, it's on the virtual private server that Google have given you when you're running Jupyter notebooks. So if we want to run a command that's actually on the computer rather than Python, they let you do it in Jupyter notebooks by putting an exclamation mark out the front. So I want to have a look at all the locales that I can choose from, and currently there are just C, which is a very simple locale, and English in the US, and POSIX. So they're the only ones I can choose from, and these ones have got UTF-8. So say I wanted Denmark, I'd have to actually enable the Denmark locale. So I can run it as a command, locale generate the Denmark UTF-8 locale, and then it will be available. So it's generating it, and now I look at it, I can see Denmark's in the list. So now I want to use the current locale. not the current one. I want to set the locale for my output to be Denmark, but because it wasn't there at the start, it's actually not going to be available. So if I run this, I'm going to get an error, as you can see. So what I could do, if it throws an error, you have to restart the session from the runtime menu. The problem is if I restart the session, I lose all my variable data. So I need to go back, run the API, get it all from Brisbane City Council API again. Now fortunately, in the runtime menu, there's a thing there, restart the session and run all the cells that we've already run. In fact, we've run all the cells in the notebook, and I think we're right at the end. So we'll do that, restart and run all. So it'll clear all the local variables, but it'll go back to the API, get all the ferry terminal data from the Brisbane City Council again, and then it'll be able to use that new locale that was there. It's generated again. It didn't need to, because you can see this time when it ran it, it was actually available. So I could have commented out those lines to make it all a bit faster, but it's just easy enough to select that one thing. And now in Denmark, they don't use a point for showing decimals. They use commas for decimals, and similarly they can use point for separating thousands. And so now I've got it in that Danish format. Okay, well, I hope that was useful, and it's piqued your interest in F-strings, the really powerful way of formatting strings. I think even the Python people have been overcome by how successful and popular they've become as a way of formatting output. In fact, in the new version of Python, I think 13, they're going to introduce template strings, or that could be 14. And template strings are like an extension. They'll end up being called T strings because they're a string with a T out the front, and they will be able to. They'll be like F strings, but you can save them. They don't evaluate them immediately. They'll evaluate them in the future sometime once the data is available. So you can set them up at one spot and then pass them through to somewhere else where it then uses them to produce an output. So that'll be fun when they're available. And I'm not sure when our next session is going to be. I'll probably try to get another one for a couple of weeks' time. But yeah, if you've got any ideas of things that you're interested in, hopefully we'll get some machine learning topics coming up. But yeah, post on Learning to Code, or in the comments below on this video. Once I've stopped the video, you won't be able to go to the chat anymore. But you can add comments to it, and we'll see what we can do. And thanks for all your thanks.